My name is Massimiliano Maule and I'm currently working as early stage researcher in Quadrat Informatica in Barcelona for the 5G STEP FWD project. I received my master's degree in telecommunication engineering from University of Trento in Italy in 2017. After that, I worked as a radio researcher and network system and architecture engineer for Nokia Solution and Network. During that period, I focused on new channel access schemes for LTE on licensed and unlicensed spectrum and innovative routing functionalities for the transport network. Being part of the 5G STEP FWD project is an opportunity for achieving new skills related to the new technologies and increase my network connections with telecom partners. I was motivated to participate in this project due to its well-structured program, composed by different trainings and collaborations all around Europe. Based on my background knowledge and previous work experience, I strongly believe that 5G STEP FWD project has the right vision to overcome the challenge of the future network systems. I'm expecting that this project will give me a complete set of skills highly valuable on the market for both academic or industrial positions. Inside the Quadrat, I have the opportunity to work with young talented researchers having different backgrounds. In addition, the strong collaboration with CTTC provides me with the sophisticated equipment useful for my research. My research topic consists of the development of a joint access and backhaul network resource allocation architecture, where all the available resources from access and backhaul are collected into a joint pool and are managed and controlled by a unified SDN control plane. The location of the SDN controllers will be optimally selected in order to minimize the delay that occurs due to long round-trip time in passive optical networks. This unified wireless and optical solution will guarantee flexibility and scalability to different types of traffic and network conditions, exploring different levels of centralization and reducing the signaling on the network. This innovative system will permit to create dense small shell scenarios with high-speed links, able to guarantee high performance to the future transport network. A secondment in another project institution is planned for my second year. During this period of 4 or 6 months, I will have the possibility to learn new technological aspects from the academic point of view, useful for my research, and I will have the possibility to increase my network connection with 5G experts.
Hello, my name is Mohammad Reza Mosaheb and I am from Iran. I received my bachelor's degree in electronics engineering from Shiraz University of Technology and my master's degree in communications engineering with the emphasis on power reduction in OFDM-based visible light communications from Tabiat Madaris University of Tehran. After finishing my master's, I decided to apply for the ESR position at Quadrat Informatica in Barcelona. I started working here at the end of August and I have already enrolled for a PhD program at UPC. The major motivation for selecting 5G STEP FWD to pursue my career is that there are different academic and industrial institutes involved in the project and I have the chance to boost my both theoretical and practical skills during these years. Not only this, 5G STEP FWD provides many training activities such as schools, workshops and different courses hosted by different contributors of this project. Apart from this, I have the opportunity to spend 6 months on my secondment at CNRS at Paris I can extend my knowledge and expertise and also receive more training on network modeling and optimization methods for ultra-dense networks. The main goals of 5G Step Forward is increasing spectral efficiency by the factor of 1000, decreasing end-to-end delay to 1 millisecond, and 90% reduction of energy consumption. In order to reach these, 5G Step Forward employs converged optical wireless networks as a prospective solution for provision of higher speeds in the access network. As my contribution in the project, I am supposed to do management and scheduling of the resources in the converged optical wireless networks. To do this, we will take the most advantages of SDN, which provides more efficient configuration, better performance, and higher flexibility to accommodate novel network designs. Besides, SDN-based resource allocation schemes consider the application of 3 5G service classes, including massive machine type communication, ultra-reliable low-latency communications, and enhanced mobile broadband. SDN-based resource allocation schemes also target to solving the multi-SDN controller optimal location problem. At the end, I really hope to make some changes and improvements in this area. Thank you.
Hi, my name is Steven Caicedo and I'm an early stage researcher at CIE Microelectronica SPA within the Marie Curie program 5G Step Forward. Before entering into technical aspect, there are two things that I would like to share with you about me. The first one, I'm from a beautiful city named Guayaquil in the Ecuador of the world. Let me show you where it's located. Second, my favorite sport game is the football and my favorite team is Barcelona, but not Barcelona from Spain, Barcelona from Ecuador. I have a bachelor's degree in telematics engineering and a master's degree in telecommunication, which I obtained at Sport University in Guayaquil, Ecuador. Concerning my professional background, I have experience in radio access network planning and optimization after having worked as outsourcing RAN engineer at Huawei Technology and quality of service RAN engineer at Claro, Ecuador. My previous work and study experience were carried out in Guayaquil, Ecuador, but in August 2018 I moved to Milan, Italy to join the 5G Step Forward project at CIE Microelectronica headquarters and start a PhD program in Politecnico di Milano. CIE and 5G Step Forward project offered me the great opportunity to boost my professional career, working and studying in a multidisciplinary environment and participating actively in the development of the 5G. My research topic is the design of antenna array for 5G millimeter wave communication. Let me show you what it is.
5G is the next generation of mobile communication system, and among other things will be 10 times faster than 4G. To fulfill this objective, wider channels are required, but the spectrum that is currently being used for mobile communication is crowded, which leads us to use the adjacent spectrum called millimeter wave. But we have a problem. Signals have more difficulty to reach their destination using the millimeter wave spectrum. To overcome this problem, we need antenna that sends signal more directly to users, but only one antenna cannot do it. For this reason, we need antenna arrays. My job is to design the architecture of the antenna array, taking into account parameters such as number and separation of antenna element, number of transmission and reception modules, among other elements. Always thinking that the antenna must be energy efficient, cost affordable, and suitable for deployment in hyperdense networks.
Concerning the project, I have expectations to see the proof of concepts of all the research activities. On the other hand, concerning my professional career, I expect to improve considerably my research skills and become an expert on 5G systems.
Hello everyone, my name is Fadil Habibidanufai from Indonesia. I'm a PhD student at LUS. I joined lab between Central Supelec, CNRS, and the University of Paris Saclay in France. At the same time, I'm also a Marie Curie early stage researcher at a European project that is called STEP FWD. I got my bachelor degree in electrical engineering from Bandung Institute of Technology, Indonesia in 2013, and then I went to Japan to do a master's degree in applied mathematics, and I got my degree from Kanazawa University, Japan in 2017. Since 2014, I have been a research assistant in an Indonesian governmental research body. It's called Indonesian Institute of Sciences, or LIPI. My research topic for 5G Step Forward project is modeling millimeter wave cellular communications via hyperdense small cell deployments. As we approach 2020, we will be soon introduced to 5G technology. This technology uses a whole new spectrum that is called millimeter wave. Millimeter wave brings a lot of benefits, but at the same time have some disadvantages such as increased band loss. Due to this problem, we need to shift our paradigm of cellular network from homogeneous network where there are only macro base stations to heterogeneous networks where we densify the base stations with addition of many small cells such as picocells and femtocells. We also need to change the way we model the network. Instead of using a rigid hexagonal model where the distance between base stations and the size of the cells are fixed and regular, we utilize stochastic geometry where we assume that the base stations and the users are randomly distributed according to Poisson distribution. These ways of modeling have been shown to be closer to the real-life network and enable us to achieve tractability for many important formulas. Using this modeling assumption, we will characterize and formalize several important performance metrics such as delay, spectral efficiency, and energy efficiency. In addition to that, we will analyze the interplay between those metrics and optimize our network using optimization theory. There are at least 3 good reasons why I chose to join this 5G Step Forward project. First is because the theme of this project matches my research interests. One of the work packages of this project is very theoretical, very mathematical in nature, and I like working on something like that. Second reason is because this project is a big project that involves a lot of people from many institutions across Europe, such as France, Spain, Sweden, and Greece. And the third reason is because this project offers a lot of supplementary courses that can support my career as a researcher in the future. So those 3 reasons are why I chose to join, and so far I'm glad that I have joined 5G Step Forward project.
I'm from China. Currently, I'm a PhD student at the University of Paris Saclay. And also, I'm an early stage researcher in the project 5G Step Forward. In 2014, I got my bachelor's degree from the University of Electronic Science and Technology of China. 3 years later, I got my master's degree from the same university. During these 3 years, my topic was about MIMO techniques based on spatial modulation.
This project allows me to study at the University of Paris-Saclay with access to the resources in the Laboratory of Signals and Systems of CNS. This huge project has strong connections with both academic and industrial institutions. And in fact, this project will have many well-rounded training activities built for us. We will be not only trained with academic skills, but also with abilities to cooperate and coordinate between different institutions. In the long term, I believe 5G Step Forward will provide me with everything I need to become a qualified scientific researcher. In our research, we use stochastic geometry to model the locations of base stations and mobile users. From the picture, we can notice that the traditional lattice model is not a good choice to model the actual locations. However, with stochastic geometry, we can use a Poisson model in a tractable way. To motivate our loss model, we use random shape theory. For simplicity, the buildings are modeled as line segments rather than as rectangles of fixed height. This makes the analysis easier without modifying the conclusions. The considered system model is depicted as follows. We can observe from the picture that if the height of the building is bigger than hy, the building will become a blockage, vice versa. In general, the heights will have a big influence on the coverage probability. In order to investigate this influence, we need to figure out how the coverage probability changes with the heights. In the long term, we should generalize this problem because in reality, all the heights of base stations and buildings are randomly distributed. Thank you.
Hello everyone, my name is Asma Ibrahim. I am an early stage researcher at CTTC in the framework of Marie Curie 5G Step Forward project since 2015. Before that, I worked as a teaching assistant at the International Academy for Engineering and Media Science, and I got my master's and bachelor degree with honor from Faculty of Engineering, Cairo University. During my master's research, I worked on visible light communications as a promising 5G technology that enhances the system capacity and security using very wide unlicensed bandwidth.
Hi, I'm Hossein Ismaili from Iran. I'm an early stage researcher here at CTTC, and I'm going to be a part of 5G Step Forward project. I got my Bachelor of Science degree from Khaja Natsir University of Technology in telecommunications, and after that I got my Master of Science degree in communications from Sharif University of Technology. During my Master of Science, I was working on OFDM and CDMA optical networks, and I got that I'm really interested in this topic. After that, I was working about a year and a half in a company, and my job was mainly focused on PON, DWDM, and OTN services. The reasons why I started this project was the fact that I found that in 5 or maybe 10 years, the 5G will be an inevitable part of every single person's life. So it is better to learn as much as we can about the next generation of cellular networks. Especially in this project, I am working at CTTC. In CTTC, we have a great combination of industrial part and the technical academic research topic. So it will be a great opportunity for me to be prepared for my future. Also, we have a great members and staff here, which I can learn and I can collaborate with, and I'm quite excited.
My work on visible light communication motivates me to join 5G STEP FWD project to add to my experience and knowledge, as this project aims to produce qualified researchers through attending different conferences, schools and settlements, and with a cooperation between industrial and research sectors. At CTTC, our team, me, Hussein, and our supervisor, Professor Christos, are working on different 5G technologies that enables 5G to achieve its aims.
It's been nearly 3 months that I've been here, and I really enjoyed this interesting place and communicating with talented people here. My project will be mainly focused on the wireless optical convergence in the front hall of the 5G networks. And the goal of my research is to use and exploit the concept of slicing into the problem, and using the slice management in order to provide better quality of service for the users. More especially, I think using the new methods and techniques like game theoretic approaches or machine learning approaches can be very helpful in order to solve this problem in the best way.
For me, 5G network slicing is introduced as an emerging technique that enables different services to share the underlying infrastructure. As 5G network has to support different services as enhanced mobile broadband and critical communication and massive machine type communication, it also has to enhance the mobile network in terms of the traffic volume and the number of devices. I'm working on network slicing end-to-end and studying the ability of using intelligent techniques as machine learning in 5G network to support different services with different quality of service. I started with radio access network slicing.
Hi, my name is Lei Shi. I'm from Shanghai, a city of China. Currently, I work as a researcher of my Julia project, 5G Step Forward. I also work as a full PhD student at the Department of the Optical Network in Chinese University of Technology. Before joining this PhD project, I got my master's degree from Shanghai Jiaotong University, major in Information and Communication System. The reasons that I joined this project are that it has a lot of collaboration with a lot of research groups around Europe. It provides us the chance to work with some of the best researchers around the world. Moreover, it also has some training classes which will help us get the newest knowledge related to our research. So it is absolutely a great opportunity for me to continue my research and broaden my research horizon. As for my research topic, I will mainly investigate on the convergence of optical and wireless network for 5G within this project, relating to some common research areas such as UDWDM, radio over fiber. Currently, the capacity of wireless network based on CPRI interface is mainly limited by the sampling processing of ADDA. So by directly using analog signal rather than digital signal will be the next step for capacity upgradation in mobile front haul. Also, to support more users in next generation wireless network, UDWDM will be a flexible solution.
Hello, my name is Mariam Lashkari. I'm a PhD student at Chalmers University of Technology, also a Mercury researcher in 5G Step Forward project. I received my BSc degree from Shahid University and MSc degree from University of Tehran in Iran, both in electrical engineering telecommunications systems. Then I worked in Huawei Corporation for 2 years as an IP MPLS planning engineer. I was motivated to apply for this project because of its training nature. Through this project, I can do research in close collaboration with both industry and academia, mainly because of the secondment that I should attain. Furthermore, not only gaining knowledge, but also collaborating with excellent researchers from different research institutes in this project is possible, and I can get quite amount of experience from this. Most importantly, the topic of my PhD research is completely new and in line with my research interest, so I can build a strong scientific background, nurture my ideas, and publish fruitful papers. Being a PhD student at a well-known university like Chalmers will help me to improve my scientific knowledge because of the courses that I should pass. Moreover, I have regular meetings with my supervisor and provide me with excellent guidance. I expect to attain valuable experience by doing research in a big European project like 5G STEP FWD and be prepared for my future career. There are some essential skills that a PhD student should learn, and by the training and schools which are offered by this project, I think I can achieve the target. As we know, the 5G network is expected to meet certain requirements such as 1000-fold system capacity, 100-fold energy efficiency, milliseconds, end-to-end latency, and connectivity for a large number of devices compared to 4G network. There are various enabling technologies such as a cloud-based radio access network. My research is focused on proposing an efficient solution for achieving a converged optical wireless fronthaul backhaul in C-RAN for the 5G network. Also, by using network slicing, virtual networks can be created to meet the requirements of different service providers, and it can prepare a multi-purpose platform for the 5G network. Without any doubt, network automation and machine learning algorithms can be used to improve the performance of the network, and I will use this applicable tool in the considered system model. Since this topic is a key challenge for the 5G network, I think I can have an actual contribution in this area.
Hi, I'm Eugenio Ruggeri. I'm an Italian engineer and I was enrolled in the 5G STEP FWD project in June 2018. Before that, in my background, I have a bachelor degree in electronics and telecommunications engineering and a master degree in telecommunication engineering, and I took both degrees from the University of Bologna in Italy. I joined the project in order to further continue my studies and to go even deeper into technical and professional details in what is the world of the research. I immediately realized how important and how great it is to work with other brilliant early stage researchers all around Europe in terms of skills, diversifications of ideas and culture. I work at the Balkan Center, which is a dislocated research center of Aristotle University of Thessaloniki. I found myself in an amazing working environment, starting from the colleagues, going to the supervisor. It was unbelievable to realize how many ideas and how many possibilities a lab like ours can offer in order to take ideas, generate ideas and make them a reality. I've been working in the lab for several months now, and I've been acquiring all the necessary skills and knowledge in order to operate such a complex and complete environment. But now, thanks to what my colleagues told me and thanks to the work of my supervisor, I will definitely be able to perform all the work related to the project. My role in this project is to work on the backhauling of the new 5G cellular network. Basically, the backhauling is the backbone of the cellular network. I will be operating optical fiber networks, keeping in the meantime an eye on the financial aspects. In this way, at the end of the journey, we will be able to actually deliver a real system for backhauling the 5G network.
Hi, my name is Omar Farooq. I am from Pakistan. I did my bachelor's degree in electronics engineering from University of Engineering and Technology, Texla in 2013. After completing my bachelor's degree, I have done my master's degree in electrical engineering from Comsat Institute of Information Technology, Islamabad. After completing my master's degree in electrical engineering, I have worked in Pakistan as a research engineer in Wateen Telecom Limited, Islamabad. In June 2018, I have been selected as a Marie Curie early stage researcher in Aristotle University of Thessaloniki, Greece. Moreover, I have been registered as a PhD candidate in Department of Informatics in Aristotle University of Thessaloniki under the supervision of Dr. Pliros and Dr. Amalia Milu. It's a unique and an incredible opportunity for me to work in both academia and industrial sector organizations in a multicultural environment. I also have an opportunity to travel across Europe while taking part in different plenary meetings, different industrial schools, different conferences, and moreover I will also take part in my secondment which will take place in CI Microelectronica in Milan. Here in this lab, I have been working as a Marie Curie early stage researcher in 5G Step Forward project. My research topic in 5G Step Forward project is to investigate the applicability of long-reach PONs infrastructure as a fiber-based backhaul, and to quantify the cost efficiency of the deployment of long-reach PONs as compared to ultra-dense WDM PONs.
I'm Dimitris.
Hi, I'm Javier.
And we are the PhD students from Eindhoven University of Technology.
Hi, my name is Dimitris Konstantinou and I come from Greece. I finished my master's studies in optical fiber communications at the Technical University of Denmark. Currently, I'm a second-year early-stage researcher at the Eindhoven University of Technology, and I am one of the 15 members that take part in the ITN European project 5G Step Forward. 5G mobile communications are in our doorstep. Thus, my research is focused on analog radio over fiber systems for 5G. More specifically, I'm studying on the methods for optimizing the converged processes between photonics and electronics that occur within 5G mobile base stations. My ultimate goal is to design a cost-effective and energy-efficient remote radio unit based on photonic integrated circuits that will be capable of providing high quality of services to the large amount of end users within small cells. One of the reasons why I joined this project is the fact that I will have the chance to collaborate with early-stage researchers coming from countries from all over the world. Furthermore, by following the 5G Step Forward schools and seminars, I will acquire all the necessary tools in order to become a skillful researcher in the future. Thank you very much.
Hi, I am Javier and I come from Spain. This year, I finished my master's degree studies in telecommunication engineering at the University of Malaga. I just started my first years of research at the Eindhoven University of Technology. Moreover, I am one of the 15 members that take part in the ITN European Project 5G Step Forward. 5G mobile communication networks are in our research environment. My research is focused on modulation format for analog radio over fiber 5G systems. More specifically, I am studying the modulation technique for enabling the transmission of microwave signal over ultra-dense WDM pounds. Furthermore, the innovation solutions that my project will offer are based on the security in the end-to-end physical layer through the hybrid photonic wireless optical links. At this moment, my main goal is to perform one state-of-the-art analysis within my topic. In further step, I will proceed with theoretical analysis and experiments. The two main reasons why I joined this project are to collaborate with a multicultural research environment and to improve my research skills. Thank you a lot and bye bye.
Hello, my name is Kabadet Sama and I'm Ethiopian. About my educational background, I received my bachelor's degree in electrical engineering from Hawassa University in Ethiopia. It was in back 2009. Then after graduating from the university, I started working in Ethiopian telecom operator, now rebranded as Ethio Telecom. During this period, I developed some interest in studying optical communication and also photonics in general. So I received the Rasmus Mundus Master's Scholarship and I studied Masters on Photonic Networks Engineering. Now I am an early stage researcher in the 5G Step Forward project at 35 Lab here in France. And my PhD involves two key concepts. One is we are dealing with passive networks. That means we have no amplification in the field. That means in between the central office and device before the end user. And we intend to increase the number of optical channels so we can accommodate more and more number of users. I can mention several advantages of joining this program. First of all, I'm interested in studying the physical layer of optical communication systems. Then I saw the structure of this program, and there is a lot of collaboration between different institutions and also between the early stage researchers. And also there is a mobility which allows us to move to other labs and work there. So it is more of an international collaborative environment, which is interesting for me. For the last couple of months, we were testing reflective devices. Reflective in essence that we have a reflective modulator integrated with optical semiconductor amplifier integrated on the same chip. So we were testing them in static mode and we have some results, and our plan is to continue testing them in